Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video, we will be working on section or checkpoint 5.18. This is coming from section 5.5, the alternating series test. We want to determine whether this series converges or diverges. So the series is the sum as n goes from 1 to infinity of -1 to the n plus 1 times n, all divided by 2 to the n. The alternating series test says that if you have an alternating series, which is a -1 to some power times some other sequence b sub n, this series is going to converge if two things happen. So two things have to happen. One of them is saying that b sub n plus 1 is going to be always less than b sub n, as long as they're all positive. So this is saying that this is non-increasing. It's going to be decreasing. And the second one says that the sequence has to approach 0. So we want to show both of those. In showing the first one, we have b sub n plus 1 less than or equal to b sub n. And so this is equivalent to saying b sub n plus 1 divided by b sub n is less than or equal to 1. So sometimes this might be a little bit easier if we take a look at the ratio of two consecutive functions or two consecutive terms in the sequence and see if that's going to be less than or equal to 1. So let's go ahead and show that first. Well, maybe before we do that, let us just be clear about the series that we're dealing with. So we have the sum as n goes from 1 to infinity of -1 to the n plus first power times n divided by 2 to the n. So clearly this is our sequence b sub n that we're going to be testing. All right. So our first part of the test, we will take the ratio of two consecutive terms. Let's take a look at b sub n plus 1 divided by b sub n, and hopefully we can show that that is going to be less than or equal to 1. All right, b sub n plus 1 is going to be n plus 1 divided by 2 to the n plus 1, and we will divide that by b sub n, which is just n divided by 2 to the n. Whenever we do this division, we consider doing the multiplication of the inverse, 2 to the n plus 1. So n plus 1 divided by 2 to the n plus 1 times 2 to the n divided by n. All right. Now at this point, we want to see how this simplifies. I have 2 to the n times 2 in the denominator for the first term, so I can think about canceling one of those, and then I'll have a 2 in the denominator, and then I will have an n plus 1 divided by 2n. Okay, let's see. Do we know that this is going to be less than 1? I think what we could do is we could just try some points, saying what if n was equal to 1? What will we get? We will get 1 plus 1 is 2, 2 times 1 is 2, so this is going to be 1. Well, it's not less than, but it's less than or equal to 1. Okay. How about when n is equal to 2? When n is equal to 2, we're going to have 3 in the numerator, or in the numerator, 2 plus 1 is 3 divided by, and the denominator is 4. So that's less than 1. That checks out. And then when n is equal to 3, we will get 4 divided by, this is 2 times 3 is 6. So that's still going to be less than 1. And we can kind of see that at this point, the denominator is going to always double, while the numerator is just adding 1 to whatever n that you have. So let's take a large number, like when n is equal to 50, I will get 51 divided by 100, which is clearly less than 1. So we can see that the first condition is satisfied. and then conclude that b sub n is decreasing. All right, so that's the first one. That's I. And then now let's go to the next one, which is the double I, and simply take the limit as n goes off to infinity of b sub n. And we do this by taking the limit as n goes to infinity of n over 2 to the n. And if we do something like L'Hopital's rule, because this is going to be infinity over infinity, so if we do L'Hopital's rule using the Bernoulli symbol here, B for Bernoulli, we take the limit as n approaches infinity of the derivative of n is 1. The derivative of 2 to the n is 2 to the n times ln 2. And this is going to send it to 1 over infinity, which is going to 0. So that checks out our second condition. And between these two conditions, we can therefore conclude that the sum, the series that we were checking on, series as n goes from 1 to infinity of negative 1 to the n plus 1 of n over 2 to the n converges. Converges. So this converges as an alternating series. Another thing that you can do, and we'll probably do it a later problem, is take the absolute value of this series to see if that converges. And in this case, it actually does. You can use the integral test to show that the series without the negative 1 to the n converges if you just look at n over 2 to the n. All right, but in this problem, this is all we're looking for, so we're good, and I hope that helps. Good luck.